Dear third prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Algebra. It's Unit 2, Lesson 4. The lesson is called Direct and Inverse Variation. In this lesson, we are going to learn what the meaning of variation and what is the relation between direct and inverse variation, and how can we change the variation into an equation, okay, and how can we find the unknown. Let's start the lesson. Before explaining the lesson, we are going to learn what the meaning of variation in this introduction example. Let we have a car, and this car move during a time 1.5 hours. Now I need to make a relation between the speed and the distance. Now we have three items: time, speed, and distance. Okay, the time is constant, it's 1.5 hours, and we are going to study the relation between the speed and the distance during the 1.5 hour. Okay, if the speed equal 100 kilometers per hour, okay, then this car will cover 150 kilometer during the 1.5 hour. Now if I increased the speed to be 120 kilometer per hour, the distance will be 180 kilometer per hour. When we increase the speed, the covered distance will also increase, because we have the same we have constant time. Now I'm going to increase the speed again to be 150 kilometer per hour. The distance will be 210 during the 1.5 hour, and finally I will increase the speed to be 160 kilometer per hour. Okay, the distance will be 240 kilometer per hour during this time. Okay, by studying the speed, it will be 120, 100, 120, 140, 160. It's increasing speed. By looking to the distance, 150, 180, 210, 240, it's also increasing distance. So we have here increase of speed according to the increase of the distance. This one called direct relation or direct variation. So what's the meaning of the direct variation? The direct variation means two items or two objects or two variables increased together or decreased together. This is the direct variation. Now, by using the same example, I'm going to explain the inverse variation between two variables. By using the same example, for example, if we have the distance, constant distance equal 300 kilometers. Okay, now I'm going to study the relation between the speed and the time during the 300 kilometers. If the speed is 50 kilometer per hour, then the car covered 300 kilometer in what time? It's in 6 hours. Okay, if the speed is 100 kilometer per hours, then the car will cover this distance in 3 hours. If the speed is 150, then the car covers this distance in 2 hours only. If the speed is 200 kilometer per hour, then the car will cover this distance in only 1.5 hours. Now, by looking to the speed 50, 100, 150, 200, it's increase of the speed. By looking to the time 6, 3, 2 and 1, it's to 1.5. This decrease of a time, here we have speed increase and here we have decrease. This is inverse relation or inverse variation. So what's the meaning of the inverse variation? The inverse variation is a relation in which between two variables, in which one of them is increase and the other decrease. Okay, let's study another example about the direct and inverse relation. if we have this rectangle, we all of them know that the rectangle included the dimension length and the other dimension called width, and the area of the rectangle is equal length times width. Okay, now we have three items: area, length, and width. By looking, okay, the three items, if we choose that width will be constant to be 5 centimeters, okay, and I need to find the relation between length and area, so I will draw a table like this. Up, I'm going to write the length. Down, I'm going to write the area. For example, if the length equals 6, then the area equal 5 times 6 equal 30. If the length equal 7, then the area 5 times 7 equal 35. If the length equal 8, 5 times 8 equal 40. If the length equal 9, the area equal 45. If the length equal 10, the area equal 50. By looking to the length 6, 7, 8, 9, and 10, it's increasing length. By looking to the area 30, 35, 40, 45, 50, it's increasing area. So we have increase in both area and length, so it's called direct variation. Okay, we have the length increase and the area increase during the constant of the width. The width is constant. Okay, now by using the same example, I'm going to explain the inverse variation at the same example. Okay, here we have length and width. The width equal area divided by length. Okay, now I need to make a relation between the length and the width during the constant of area, or the area is constant. For example, if the area equal 24 centimeter square, to make the relation between length and width, I will draw a table like this, and here the length and here the width. For example, if the length equal 4.8, then the width equal area over length, 24 divided by 4.8 equal 5. If the length equal 6, the width equal 24 divided by 6 equal 4. If the length equal 8, 24 over 8 equal 3. If the length equal 12, 24 divided by 12 equal 2. And if the length equal 24, the width equal 1. Here by looking to the length 4.8, 6, 8, 12 and 24, it's increase. And the width 5, 4, 3, 2, 1, it's decrease. So the relation in that example is an inverse relation. Okay, now I have explained the inverse and the direct relation. Okay, now I'm going to study each variation separately and studying its rules. Okay, I will start with the direct variation. The direct variation, this is the symbol of variation. This x and y are two variables, and this is the symbol of variation. Read as y varies directly as x. Okay, now in mathematics we don't use this symbol varies, so I will change this one by two different rules. The first rule like this: y equal mx. This one called relation between x and y will change the direct the variation sign into equal and m. Again, will change this symbol into equal and m to be y equal m times x. Now I bring to you the previous table from the previous example to study this relation by using this rule. Okay. For example, if the length of the rectangle is x and the area is y. Okay, this is a direct relation as I explained before because the length increase and the width and the area increase. Okay, by looking here, 30 equals 6 times 5 and 35 equals 7 times 5 and 40 equals 8 times 5, 45 equals 9 times 5, okay, 50 equals 10 times 5. So y equal x times 5. So by looking to this example, okay, okay, then y equal 5 times x. This is, for example, using this example. Okay, now I'm going to explain the other relation or the other rule. Okay, but I will choose two different values for x and two different values for y, like this. By looking to x and y here, I will call this one x1, and this is x2, and this is y1, and this is y2. So I will start with y1 over y2, which is equal 30 over 35. By making a simplify, 30 over 35 divided by 5, it gives me 6 over 7. 30 over 35 is y1 over y2. 6 over 7 is x1 over x2. So the rule will be like this. y1 over y2 equal x1 over x2. And this is the rules of the variation. If y varies as x, then y equal mx, or y1 over y2 equal x1 over x2. When do we need to use this one and use this one? If he asks me, write the relation, then you have to use this one. If there is a missing term, then you can use this one. But the better one, or the general rule for all the problems which makes you solve all the problems, is this one. This is the general rule. I can solve any problem by using y equal mx. Okay, now I'm going to explain the graphical representation of the direct variation. Okay, the direct variation by using the previous table. Okay, by drawing the x-axis and y-axis like this. Here 6 and 30. 6 and go up to 30 here. 7 and 35 here. 8 and 40 here. 9 and 45. 10 and 50. This is the data from the table. Okay, now we find that we have collinear points, or the same, all of them lie on the same straight line. By connecting them like this, then we get straight line passing through the origin point. Then we can say that the direct variation is represented by a straight line passes through the origin. It's a very, very important rule. He may ask you, what is the graphical representation of the direct variation? The answer will be, it's represented by a straight line passing through the origin. And we are going to solve problems about this one. Okay. Here we have example 1. Y varies as x. Y varies directly as x. So I will write it as y varies as x like this. Okay, here we have x1 equals 7, y1 equals 20, x2 equal unknown, y2 equals 40. Okay, now find x at y equal 40. Now it's easy to use y1 over y2 equal x1 over x2. So y1 over y2 equal x1 over x2. Therefore, y1 equal 20, x1 y2 equals 40, x1 equal 7, x2 unknown. Therefore, x2 equals 7 times 40 over 20, which is equals 14. This is a value of x2. Another example, if y varies directly as x, y equals 14, y1 equals 14, x1 equals 42, y2 equal x2 equal. Okay, the first required, find the relation between x and y. Okay, this is the rule, y varies as x, therefore y equals mx. By using y1 14 and 42, therefore y equals 14 equals m times 42. Therefore, by send 42 there as a divide, then m equals 14 divided by 42, then m equals 1 over 3. Therefore, the relation is y equal, here the relation is y equal mx. Okay, then it will be y equals 1 over 3 x. This is the relation between x and y. Okay, therefore here required number 2, find the value of y when x equal 60. If x equal 60, find y. So y equal 1 over 3 times 60 equals 20. Okay, in this example, y varies as x power 3 and y equals 64, y1 equals 64, x1 equal 2, y1 is unknown, y2 is unknown, x2 equals a half. Okay, now since y varies as x power 3 like this, therefore y equals mx power of 3. Therefore, by using 64 and 2, then 64 equals m times 1 over 2, all, excuse me, it's 2, not 1 over 2. M equal 64 times 2 power of 3, then 64 equals m times 8. Therefore, m equals 64 divided by 8. Therefore, m equals 8. Therefore, the relation is y equal, in place of m I will write 8x power of 3. Here x equal 1 over 2, therefore y equal what? Y equal 8 times 1 over 2 all power of 3 equals 1. This is the value of y. Now let's explain the inverse variation. This symbol, as I said, is called varies, but here y varies as 1 over x, then it called inverse variation. Read as y varies inversely as x. Okay, now by using the previous example or the previous relation between x and y, let's conclude the rules of the inverse variation. The first rule with us, we are going to change this symbol into m to be like this, y equal m over x. Okay, by looking to this example, y equal m over x, number over x. By looking to y here, 5 equal 24 over 4.8, and 4 equal 24 over 6, 3 equal 24 over 8, 2 equal 24 over 12. 1 equal 24 over 24. Then by using this example, we get that y equal 24 over x. Now, the other rule, by choosing two values for x and two values for y, I will choose 4, 3, 6, and 8 like this. Okay, I will call 4 is y1, 3 y2, 6 x1, 8 x2. Okay, I will start with y1 over y2, 4 over 3. Okay, it's not equal 6 over 8 because 6 over 8 equals 3 over 4. This time it's equal 8 over 6 like this. Okay, to check, 4 over 3 equal 8 over 6. 8 over 6 divided by 2 equal 4 over 3. So this is an inverse relation. y1 over y2 equal x2 over x1 like this. So the other rule is y1 over y2 equal x2 over x1. This is the rules, but the general rule is the equation rule is this one. Okay, now if y varies as 1 over x, then y equal m over x, or y1 over y2 equal x2 over x1. Let's start to solve example 4. In this example, y varies, a varies inversely as b. That means a varies as 1 over b like this. Okay, and a1 equals 12, b1 equals 8. Find a2 at b2 equal 1.5. Okay, here we have, I will use the easier rule, a1 over a2 equal b2 over b1. Therefore 12 over a2 equals 1.5 over 8. Therefore a2 equals 12 times 8 over 1.5, which is equal 64. Example 5, y varies as 1 over x and y equals 3 when x equal 2. Find the relation between x and y, and number 2, the value of y at x equal 1.5. Okay, now I will write the given here. y1 equals 3, x1 equal 2, y2 is unknown, x2 equals 1.5. Okay, the relation between x and y. First, since y varies as 1 over x, then y equals m over x. By replacing 3 and 2 from here, so 3 equals m over 2, send 2 there as time, then m equals 3 times 2, 6. Therefore the relation is y equal 6 over x. This is the relation between x and y. Here find y at x equal 1.5. Therefore y equals 6 over 1.5, which is equal 4. Okay, another example. In this example, y power of 2 equal varies as x power of 3. Find the relation between x and y at y equal 3 and x equal 2. Okay, first y power of 2 equal mx power of 3. Therefore, by using 3 and 2, therefore 3 power of 2 equals m times 2 power of 2, then 9 equals m times 4, 2 power of 3, excuse me, times 8. I will send 8 there, therefore m equals 9 over 8. Therefore the relation is y power of 2 equals 9 over 8 x power of 3. This is the relation between x and y. Example 7. This example, 5x minus 3y over 3x plus 5y equal 1. Okay, for all the values of x belong to r positive and y belongs to r positive, prove that y varies as x. Okay, to prove that y varies as x, then we need to prove that y equal mx, and m is number. Then we need to prove that y equal number times x. It's very easy. By using the properties of proportion, I'm going to make a cross multiplication. Then it will be 5x minus 3y times 1 equals 3x plus 5y. Here we need y in the left side, so I will collect x in the right side and y in the left side like this. It will be like this. Negative 3y minus 5y equals 3x minus 5x. Negative 3 minus 5 equals negative 8. Y equals 3 minus 5 equals negative 2x. I will send negative 8 there to be divided. Y equal negative 2x divided by negative 8. Therefore, y equals negative 2 divided by negative 8 or over negative 8 equals quarter. X, this is the relation. Therefore, y varies as x. It's very easy. Here we have x power of 2, y power of 2 minus 6xy plus 9 equals 0. Now we have a perfect square trinomial. It will be like this. xy, okay, minus root 9 equals 3, all power of 2 equal 0. Don't forget, I took here root x power of 2, y power of 2, and here square root 9 here. Okay. X minus 3y all power of 2 equals 0. Therefore, xy minus 3 equal 0. Send 3 there. Then xy equal 3. And I need to prove y varies inversely as x. So I will send x there to be like this. Y equals 3 over x. Now, y equal 3 over x exactly as y equal m over x. Therefore, y varies as 1 over x. This is an inverse variation. Now, example 9. In this example, x power 4, y power of 2 minus 14, x power of 2y plus 49 equals 0. Prove that y varies inversely as x power of 2. I need to prove that y equal m over x power of 2. This is a perfect square because we have square and 49 is a square. Okay, so I will open bracket power of 2 and the negative sign here. Square root the first equal x power of 2y. Square root the last equal 7. Here equal 0. Okay, then x power of 2y minus 7 equal 0. I will send 7 there. Then x power of 2y equal 7. Now I'm going to send the x power of 2 there. Then y equal 7 over x power of 2, or y equal m over x power of 2. Therefore y varies as 1 over x power of 2. Now example 10. In this example, show the type of the variation between x and y. First, from the data in the following table, answer the following questions. Show the type of variation between x and y. Okay, by looking to x, here we have 2, 4, and 6, it's increase. By looking to y, 6, 3, and 2, it's decrease. So we have here increase, and here we have decrease. This is an inverse relation between x and y. So, number 1, y varies as 1 over x. Okay, the second required, find the constant of variation. Okay, since they are a variation, an inverse variation, therefore y equal m over x. Okay, by choosing 2 and 6, for example, by put in place of y 6 equal m over 2. I will send 2 there. Therefore m equals 6 times 2 equals 12, and this is the constant of variation. Number 3, find the value of y at x equal 3. Okay, the relation is y equals 12 over x. At x equals 3, therefore y equals 12 over 3 equals 4. Number 4, by using the same relation, at y, find the value at y equal 2 and 2 over 5. Y equals 12 over x. Therefore 2 and 2 over 5 equals 12 over x. Therefore 5 here, and 5 times 2 plus 1 equals 12 equals 12 over x. Therefore x equal 12 times 5 over 12 equals 5. Okay, now I'm going to solve example 11. In this example, y equals a minus 9 and y varies inversely as x power of 2, and a equal 18 at x equal 2 over 3. First, find the relation between x and y and deduce y at x equal 1. Now we have three variables, x, y, and a. Okay, here the given included a and x. Now I need to find the relation between x and y. Okay, first, by using y equal a minus 9. Okay, here a equals 18 at x equals 2 over 3. By putting a equal 18 in place of a, then y equal 18 minus 9 equal 9 at x equal 2 over 3. Now y equals 9 at x equal 2 over 3. By those two variables I can find the relation between x and y. Since okay, by using this relation y varies as 1 over x, therefore y equal m over x power of 2. Okay, by substitute x and y from 9 and 2 over 3, therefore 9 equals m over 2 over 3 all power of 2. Therefore 9 equals m divided by 4 over 9. I will send this one as a divide. Therefore m equals 9 divided by 4 over 9. M equal 9 times 4 over 9. Therefore m equals 4. This is the value of m. Therefore y equal 4 over x power of 2. This is the relation between x and y. At x equal 1, therefore y equals 4 over 1 power of 2 equals 4. Number 12. If x equal L plus 9 and L varies as y, then find the relation between L and y. Knowing that x equal 24 and y equal 5, then find the value of y at L equal 12. Okay, here x, I need to find the relation between L and y. Okay, here by putting, so since he needs the relation between L and y, then I need to cancel x. It's very easy. By putting here x plus L equal 9, then L equal x minus 9. At x equal 24, then L equal 24 minus 9 equals 15. So L equal 15 at y equal 5. Okay, now L equal 15 and y equal 5, and y varies as L. Since L varies as y, therefore L equals my. I will put here L equal 15 and y equal 5, so 15 equals m times 5. So m, it's easy to know that m equal 3, or m equal 15 divided by 5 equal 3. M equal 3. Therefore the relation between L and y, and L equals 3 y. This is the relation between L and y. If L equals 12, then y equal 12 equal 3y, then y by send 3 divide, therefore y equals 12 divided by 3, then y equals 4. Example 13. Okay, the graph which represents the direct variation between x and y. I need a straight line passing through the origin. As I explained before, the straight line that passing through the origin is this one. Number 2, which of the following direct variation between x and y? X times y equal 5. This is an inverse relation, because if I send x there, it will be y equal 5 over x. This is inverse relation. The variation doesn't include plus or minus. X over 3 equal 4 over y. This is inverse relation, because here x equal number over y. X over 5 equal y over 2. If I send 5 there, then x equal 5y over 2, and this is a direct relation. Which of the following represent inverse variation? The inverse variation here is x times y equal number. Okay, this is included plus, it's not variation. This is a direct relation. This is a direct also, because if I send y there, it will be x equal 5 over 7 times y. Y varies inversely as x. Okay, then y equals m over square root x. Okay, I need a root x. Okay, therefore I will make it over 1. Root x equals m times 1 over y. It will be m over y. I need x, therefore x equal, by squaring both sides, it will be m power of 2 over y power of 2. Then x varies inversely as y power of 2. This is the answer. Number 5, y minus 4x plus 4x plus 4x power of 2 equals 0. This is a perfect square. I will write root y power of 2 here and root 4x power of 2 here equals 0. Then y minus 2x equals 0. By sending 2x there, then y equal 2x. Y equal 2x, then y varies as x. Now, example 14. The height of circular cylinder where its volume is constant varies inversely as a square of radius r. That means h varies inversely as 1 over r power of 2, where h1 equal 27, r1 equal 10.5. Find h2 where r2 equal 15.75. Okay, here h1 over h2 equals r2 power of 2 over r1 power of 2. Therefore h1 27 over h2 equals r2 power of 2 15.75 all power of 2 over 10.5 all power of 2. Then h2 equals 27 times 10.5 power of 2 over 15.75 power of 2 equals 12, and the height here with centimeters. The next one, a car moves with a uniform velocity where the distance varies. The distance, I call the distance d, varies directly as the time t. Okay, directly as t, d varies as t. Okay, if the car covered distance 100, d1 equals 150, d1 equals 150 in 6 hours, t1 equals 6 hours, and find the distance covered. Find d2 in 10 hours. Okay, here we have direct variation, then d1 over d2 equals t1 over t2, therefore 150 over d2 equals 6 over 10, therefore d2 equals 150 times 10 over 6 equals 250, and the distance here with kilometers. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.